On to Module 4. Here it comes. Is it up there?
Nope, not yet. Just a blue screen.
Blue screen. Oh, you got homework for me, right?
Yes.
Homework. Make sure the heading's right. Make sure it's folded right. Get all your fringe off. And then pass them. As you pass them, if you just keep them stacked the same way, oriented the same way, and I'll collect them over here. Is it up there now?
No.
What? Oh. No wonder. Okay, so as for the exams, I gathered up all your Scantrons and I brought them to the processing center this morning. And usually when I get them there in this morning, they give me results in the afternoon. Usually. Shouldn't take me too long to crunch the numbers and put the results up on Blackboard. So what you'll get is, you'll get a raw score. That raw score will be in your My Grades. And then sometimes there may be a little formula that you'll do on your raw score to get your actual test score, and then I'll put that on announcements. Okay? So you get your raw score off your grades, and then look for instructions and results on announcements on Blackboard. Okay? So we're pressing on to Module 4. So here's the situation. We'll talk through the situation, and then you're going to have some time to work through this worksheet. We're going to do most of worksheet 1 today in class. So it says, when you were 12, your father decided to start saving for your college education. And since he was getting a late start, he decided to increase the investment in your education each month in the very conventional way of placing 1 penny on a chess table. And then at the end of the first month, he doubled it. He placed 2 pennies on the first square. So imagine that there's, you don't have to imagine, I can draw it. I guess pennies are closest to red, so I'll do red. So, first penny is off the table. Okay, first penny is off the table. And then, after 1 month, he doubled it, put 2 pennies in square 1. Then at the end of the next month, he doubled what was in the last square and put 4 in square 2. And he continued that pattern of doubling until the chessboard was full. Does the basic setup make sense? I think. Yeah. So the key is that the 1 started off the board, and after 1 month, he doubled it and started on the board with 2. So we got different ways of notating these quantities. So we'll represent the number of pennies on each square in 3 different formats that will help us generalize the mathematics. Okay? The first is decimal notation. That's just the number of pennies. So if we're talking about the 4th square, we just say decimal notation says there's 16 pennies. If we're talking about product notation, where did that 16 come from? Right, so we had the 1 penny to get the first square, multiplied by 2, right? And then to get the second square, multiplied that by 2. And then third square, so 4th square is actually having multiplied 2 together 4 times. So we want to represent it in that product notation. And then here's the short way to do that. So when you multiply a number together 4 times, that's what it means to raise that number to the 4th. So the exponent is the number of times that you multiply this number together. Number of times you multiply that times itself. So those are the 4 different, the three different representations. And so you're going to answer a couple questions, then you're going to fill in the table, which is referencing those different notations. Let's see how far we can get here before I break you. Well, have I done that yet? Let's see. Let's just go all the way. Try to make it all the way through 4. So you'll have a considerable amount of time here. So those 2 pages, 135 and 136. Page 135 and 136. Make sure you understand and have correct each question before you move on. It builds on itself. So if you rush and you make an error in your thinking, then from there on out you're going to be off. So go slow. Yes, sir. Yeah, nice. Okay, if you want to, should be, there we go. If you want to check your table, here's the table. So, let's talk about this. Let's see this as a function. What would be the natural input quantity for this function? What's natural as an input quantity for the function? What quantity?
What square number you want?
They want the square number. Is that natural? That you would have a function that you would take the square number, and what would you do with it? It would give you the output of number of pennies. Does it feel natural? Yeah. So this is input. Input, and that's the function that you build on the next page. Input and output. How many pennies are on the product notation is really, I think, the most helpful thing to see what's going on, in the situation. What happens every time we advance 1 square? It doubles from what was on the last square. Always times 2. So, what kind of growth is it? We're always multiplying by 2. So we have what kind of growth? Well, yes, it is exponential growth, but what is characterizing? What operation characterizes exponential growth? What is it that we do to get to the next output value? You multiply it by the same number every time. So exponential growth is about multiplication. The exponent is just this convenient way of representing, so we don't want to write out 14 twos. But it's 14 twos multiplied together that's the real idea here. But we don't want to write out 14 twos. So we just have this convenient way of expressing that We're taking 2 and multiplying it together 14 times. That's the real idea of an exponential function. Repeated multiplication. Repeated. And I'm going to repeat that many times, so you're going to find out, because it takes a long time to sink in. Repeated multiplication. That's the name of the game here. And conveniently, we always use the same number when we repeat the multiplication. So it's as easy as it can be. We've got this one number, and we keep multiplying by that one number to get the next output value. What number are we multiplying by here? 2. This is repeated multiplication by 2. So, 2 to the 5th. How many times did we repeat the multiplication of 2? 5 times. Okay? So, you've got an output value. Always to get to the next output value, you do what? You've got an output value. To get to the next output value, you multiply by 2. How are we going to get the next output value, which would be on the 15th square? What are we going to do to the previous output value? Multiply it by 2. So we're going to take that thing, and we're going to multiply it by 2. And it'll be how many 2's then? This is the idea of exponential growth. Exponential growth means if you advance one number of input, the output gets multiplied by, well, in this case 2, but it could be any number. It could be any number. But that number in a particular function will stay the same. Okay, so I'm going to sound like a broken record in the next couple of weeks because it's my experience. This is a kind of a new idea. A new idea. What are exponential functions about? They're about repeated multiplication of a factor, okay? Of a factor. In this case, doubling, so the factor is 2. So a function f, we said what's the input? And square number is the input. And then how do we get the number pennies on the nth square?
2 raised to the n.
Which means what?
2 repeated by the number or sort of square that it. That so
Try it again.
So you multiply 2 by the number of I understand. I don't know how to explain it.
Exactly.
So you multiply 2 by itself with the number in.
As many squares as there are, as many squares as we've gotten up to, we're going to multiply 2 together that many times, n times. Yeah, so here's how we can represent that. So we're going to start multiplying 2's, right? And then how many 2's will we have? N 2's. So with dot, 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 we can represent, so like 2 to the 64th. Many of you opted not to do that, right, in the product notation. How can you can still do the product notation quickly, just by what I just did. You can go 2 times 2 times 2, and say, okay, heck no, I'm not writing 64 of these. But I can just say, all right, look, 64, 2's. Is it fair? Doesn't it? It communicates the same thing. Yes, ma'am.
I put 2 to the 64th next to there. It's like 1.8 or
It's so big it did something funny, didn't it? What did it do? Yeah, there's not enough room on your window screen to show what that number would be, so they have a way to take care of that. So what number was it? 1.8, and then they said E19. What that means is 1.8. Give me one more decimal value there. And then one more. 8.04. So E19 means move the decimal place 19 spaces to the right, or times 10 to the 19th. So there's not, you don't have 19 spaces on your screen, but we can still show that number this way. So if you move that over, it'd be 1804, and then what, 16 zeros? 10, 11, 12, 13, 14, 15, 16. It's like this is almost as much as our national debt.
Yeah.
Think you'll be able to afford college? And that's just how many pennies are on the 64th square. What about all the other squares? This is not adding up all the pennies on the whole board. This is just how many pennies are on the last square. Okay? So, it's a lot of money.
Just divide it by 100. You have enough, trust me.
Okay. Percent increase. What's the percent increase from? So as the square number increases from 2 to 3, what does the pennies, how many pennies on square 2? 4. How many pennies on square 3? 8. So what percent increases that? And you have 4 pennies, and then you have 8 pennies. By what percent did it increase? Some are saying 100, some are saying 200. How many pennies did it increase by? How many pennies did it increase by? 4. We added 4 pennies. So really we're comparing that 4 to the original value and saying what percent of the original value did it increase? So it increased by 4, and our original value was 4. So what percent of 4 is 4? It's 100%. Because it's the same, you had 4, you increased by 4. So you increased by 100% of what you started with. Okay, so here's where some of us ran into trouble, but some of us got it. So now, we really got to understand the situation. We start with 3 pennies off the board. And then what do we do? So what's really helpful here is to make this table that we had on the previous page. So we got the square number and then number of pennies. I'm doing this one up here. Okay? So we can think of off the board kind of like the 0th square. Is that fair? How many on the 0th square for this up here? 3. And so then, how many on the, what do we do to that 3, according to the situation, to get how many are on the first square? So here's where the product notation is so crucial. It really helps you form this function, see what's going on. Wouldn't that be 3 times 2? What do we do to that to get the number of pennies on the next square?
3 times 4.
We're going to take what we had before and do what to it?
Multiply by 2.
Multiply it by 2. It's still doubling. We're doubling what we had before. So here's what we had before, and then we double. So now, we had this before. This is 2 there. This is 3. So this is what we had on the second square. And what do we do to it? Double it. So in exponential form, if we want to, so exponential form, using exponents, how could you characterize that in exponential form?
3 times 2 to the n.
We always have a single 3. And then what happens every time we go to the next square? One more 2. So we always have this single 3. So this one is going to be 2 squared, and this one will be 3 times 2 cubed. So that function will be? That's right. What? Since we're still doubling, notice we're still doubling, there's this number that gets repeated. Repeated multiplication. Repeated multiplication. The square number then is how many times we've doubled, not multiplied by 3. So if you put 3 to the end, what in effect were you doing to the pennies? You're multiplying by 3 every time you went to a new square. That's tripling the number of pennies. So that's not what it said. So it started with 3 and doubled. So if we start with 5, but we keep doubling, what will it be?
It's 5 times
2 to the end. Okay, so now we're going to put 7 on the table, and we're going to triple the pennies each square. So we're going to put 7 on the table and triple the number of pennies each time. That's the next. Oh, and there you go. There's the answer. Yeah. It didn't. There we go. Okay. So we're going to put 7 on the first square, and then triple each square. If you're not sure, what can you do? Make the table. 0, 1, 2. These are the square numbers. So on the 0 square, how many pennies? 7. What do we do to get the first?
7 times 3.
Triple what we had before. Take what we had before and triple it. Take what we had in the last square and triple it. Oops. That was the last square, and there's the triple.
No, you're right. There's 2 3s.
Take what we had before, which was 7 times 3 times 3, and triple it. So now it helps you to see. So in the nth square, you're going to have a 7, and then what?
Times 3 to the nth power.
But what will we have? But what? So before you jump to 3 to the n, what does that mean? What will we have? 7 and then? 3 n's?
Multiplied by
3 times the number of 3 times square the number of 3 that is in. I don't know.
In general, what's happening in the parentheses? We multiplying a bunch of 7s together? 2s? 3s. We're tripling each square, so we keep multiplying by 3. So the question is, in the nth square, how many 3s? N 3s. We've multiplied by when we get to the nth square. So it's 7 times. Look, there it is again. Repeated multiplication, but this time by 3. Every time we advance a square, we multiply by that same number. So you got the old output. To get the new output, you do what? Multiply by 3. If you're doubling, you got the old output. You want the new output, what do? Multiply by 2. Every time you advance the input by 1, the output gets multiplied by this very important number, whether it's 2 or 3 we've seen so far. Have a great weekend.